Stop calculating 7 by 1. That rule is completely wrong. Science has proven it. 1 dog year is equivalent to 30 human years. The scariest part, if he is overweight, his biological clock runs 15% faster. In this video, I'll show you the only test to reverse this and give him extra years.
But is it right? I mean, the second you start to really think about it, the whole thing it starts to fall apart. This simple little multiplication trick doesn't really line up with what we actually see in a dog's life. So let's just call it what it is, the multiply by 7 myth. Yeah, it's a popular rule of thumb for sure, but it's a huge oversimplification that just completely ignores some key biological facts. Okay, here's the biggest problem with the 7-year rule. A 9-month-old dog, it can have puppies. But if you do the math, that would make them the equivalent of a 5-year-old kid? See? The timelines just don't match up. Not even close. And it's not just me saying this. A researcher, Trey Eidecker from UC San Diego, he puts it perfectly. He says, it makes sense when you think about it. A 9-month-old dog can reproduce, so we kind of already knew that the 1-to-7 ratio wasn't right. The evidence was right there in front of us the whole time. So, okay, if the old rule is totally wrong, what's the right way to figure it out? Well, the answer, it turns out, is in some really cool new science. Instead of doing simple math, researchers are now using something called an epigenetic clock. It's a way more accurate method that measures what they call wrinkles on a genome. How cool is that? Okay, epigenetics. What on earth is that? Well, think of your DNA as like a giant instruction manual. Epigenetics are basically the sticky notes and the highlighter marks on that manual. They tell your body which instructions to read and which ones to skip, and they do it without actually changing the words in the book. And these marks, they change as we get older, creating those wrinkles on our genome. So to figure this out for dogs, scientists tracked these very specific epigenetic changes. It's a process called DNA methylation in 105 Labrador retrievers. By mapping out how these sticky notes changed over time, they could directly compare the dog aging process to our own and create a much more accurate timeline. And what they found is, wow, it's pretty fascinating. A 1-year-old dog isn't like a 7-year-old kid at all. Nope, they're biologically closer to a 30-year-old human. It turns out dogs age incredibly fast in that first year, but then the whole process slows way down. So by the time they're 7, they're closer to 62 in human years, not 49. Aging just isn't a straight line. But hold on, this story gets even more complicated because, as you know, not all dogs age the same way. And this brings us to a really interesting biological puzzle, what's known as the big dog paradox. Okay, think about this. Usually, when you're comparing completely different animals, bigger means a longer life, right? An elephant is going to outlive a tiny mouse. But, and this is the weird part, within a single species, like dogs, the rule completely flips on its head. Smaller dogs, like Chihuahuas, actually live way longer than big dogs like Great Danes. It's totally counterintuitive. And the difference is, it's really stark. A Great Dane's average lifespan is tragically short, sometimes just 7 or 8 years. But a little Chihuahua, they can easily live past 12, sometimes much longer. So there's this really clear biological trade-off happening between a breed's size and how long it gets to live. And it's not just about how long they live either. It's also about how they age. Large breeds, because they grow so fast, are way more likely to get things like arthritis and certain cancers. Small breeds, on the other hand, they tend to face a totally different set of challenges as they get older, like diseases of the nervous system or metabolic problems. So all of this begs a really interesting question, doesn't it? What about us? What about humans? If this whole size versus lifespan thing exists for dogs, could the exact same pattern apply to our own height and how long we live? A surprising amount of research is starting to suggest that, yeah, it does. On average, across large populations, studies have found this strange correlation where shorter people tend to have longer lifespans. Now, this is not an absolute rule for any single person, of course, but it's a real statistical pattern that keeps showing up. So why? Why would that be? Well, scientists are looking into a few main theories. One idea is simple. A bigger body just has more cells, and more cells means more chances for one of them to go rogue and become cancerous. Another theory is the strain on the heart. It has to work harder to pump blood through a bigger body. And finally, the very same growth hormones that help us get tall might also speed up aging down the road. And just so you know, this isn't some fringe idea. Research on growth and aging points us out pretty clearly. This longevity advantage for smaller individuals is a recognized pattern across a ton of different species, and it really does seem to include us humans.
Okay, so let's tie all of this together. What does all this new science about aging and size really mean for us and for our pets?
All right, here are the big takeaways. Number 1, the multiply by 7 rule. It's a total myth. Ditch it. 2, aging, at least for dogs, is not a straight line. It's super fast at first, and then it slows down. 3, within a species, there's often this trade-off between being bigger and living a shorter life. And finally, number 4, the genes that control how big we get seem to be deeply, deeply connected to the whole process of aging.
And you know what? This stuff really matters. For our pets, this science helps vets give them way better care because they're working with a more accurate biological age. And for us, it's opening up these fascinating new questions about our own health and longevity. And it all started by studying our best friends.
So I'll leave you with this one last thought. The same science that completely busted the 7-year myth could also be the key to unlocking the secrets of aging itself. I mean, think about it. If we can figure out exactly why large dogs age faster, could we one day slow that process down and extend not just their lifespan, but their health span, their years of good health? It's a question that could literally change everything for the animals we love so much.